Okay.
Go ahead.
Okay. Thank you, Chairman. I'm Peng. I'm very sorry I cannot come to the workshop in person and talk with you because I will give a lecture for undergraduates this today, so I cannot get approved to leave from our university. And Dr. Zhang, Daobo Zhang from our group is there for the meeting. So if you need to discuss with us face-to-face in person, you can call him. Dr. Zhang, could you raise your hand? Could you raise your hand? And okay. And today I will give a presentation on our study on robotic construction. And I will be from the perspective structural engineer, a structural engineering researcher, give a presentation. So for us, robots are very effective and powerful tools for the future construction. It is bringing more possibility and changes for construction. Okay. I will give some start cases from the structure part. Firstly, let's look at the development of the construction. We divide the history of the construction developing into 3 stages. The first generation of the construction, we use natural materials like wood, stone, and by the human being themselves, designed by brain of person and by the hand and measurement and sensoring by eyes. This is the first generation. It's very beginning to change the natural world. And after the Industry Revolution, the human being can use some advanced tools like computer, like the machines controlled by people, and use manual measurements, included some optical instruments to assist the human being. For the material, at the same time, upgrade also. Artificial materials have been used like the concrete and steel. So now I believe we are walking from the second generation to the third generation. And for the design, we use AI. AI can complete the design based on the self-learning function. And for the construction process, we are using robots, automated robots. For the sensoring, we will use some advantages equipments. For example, radar, for the laser scanner to replace the eye, and measurements equipment in traditional. Okay. And But at the same time, I hope to I want to see the material and the structure system we need to consider to upgrade again to adapt to the new tools for design, for construction, for measurement. That is why I need I want to I need to talk. Now we have some new robot for construction in China. For example, the plastering robots developed by the Bezhilin. It can plaster 15 square meter in 1 hour. Even we developed some huge building machine for the high-rise building and the bridge, but all this robot, for example, this robot just for one procedure in construction, and the building machine for high-rise building and the bridge also controlled by the person, by the human being, so not a robot really. And but the advantage the technology gave a lot of the possibility for the structure. In the past 10 years, we built a lot of the very complicated structures using advanced technology like 3D printing, CNC machine, and some digital technologies. And this is opportunities using robots, advanced manufacture, and AI. It can they can make the more complicated structure and very complicated configuration in the building and bridge. In another hand, at the same time, the robot and advanced technology can bring people into the new construction site. For example, the deep ocean, the polar region, and even the lunar construction. So, what does it mean? That means that new technology, robots, and like robots can change the structure and use new materials. But go back to the current construction, there are two challenges. There are two challenges from the real application of the robots. One is the complexity of the construction task and the variability of the construction site. As the Professor Nichols just mentioned, the whole construction is composed of the thousands of procedures. For example, just the structural components, for example, roof, floor, and wall, manufacture, production process composed of more than 100 procedures, more than 100 crafts. Each procedure is a complicated job. For example, the marrow, for example, the assembling the rebar. Now we need the professional worker. We need the professional workers to complete each craft, each procedure. If the robot like people to replace to complete the one craft, one procedure, that means we need 10,000 robots, different robots. So this is a challenge. And another challenge is the difference between the design and the real environmental. Also consider the weather or something like this. So this is a challenge. So one thing we need we need consider we need consider we develop the advanced robots to serve the existing structure system, existing construction system. This is I can this is just the second generation concept. So in future, the structure material and the structure system are developing also. So we need to consider developing the new material and the new system to adapt the robots, adapt the. That means that we need we want to achieve the third generation of the civil engineering. One thing we are talking in this workshop, we are talking more about how to make bad robots. For example, the higher precision, great load capacity. Another thing we need to consider how to use robots better to develop new materials and the new structure system. So this is our study, the beginning of our study. So I will give some cases from this viewpoint. And for example, the 3D printed concrete. Why 3D printed have many advantages? Because it is a good procedure construction process technology to it is suitable to the robot because because this 3D printing it do not need the formwork. It do not need to use very different workers. We just need one robot machine and a pump the cement. It's okay, cement okay. But for the real application, the 3D printed concrete, we need to develop the new material. The new material means that the concrete for printing, we cannot use the traditional concrete. We don't need we just cross aggregate. It cannot be printed very easily. And this is just the case for the material. For the structures, now we reinforce the concrete. We need a steel rebar embedded in the concrete for the traditional concrete structure. But for 3D printed, the concrete wall is very weak in tension and without any reinforcement. So we need to develop some new method to adapt it to the printed concrete structure members. So we developed the FRP. It's kind of the fiber, flexible fiber, carbon fiber, can be adhesive, can be bonded on the surface of the printed concrete. So this is just the case. We use the robot print. It is very good. We don't need people to cast the concrete, but we need to develop the material and the system. So we use this system to in the real application. This is a robotic arm, and build a real house in a small village in Hebei province. And we use the new material and the new system and the new construction method. Use robot arm. And we also use this method, make a model to make a shaking table test to evaluate the behavior of the structure in earthquake. This is just a case using robot. So robot for construction. At the same time, we use a new concrete, a new structure system. And another case is the use fiber reinforced polymer. Fiber reinforced polymer means use a carbon fiber or glass fiber reinforced epoxy resin or something like this. Why this material is more suitable for robot? Because it's very lightweight and much stronger than steel, and it is durable. But in most of the case they are composed of the very thin fiber. So that means we need during the construction, we need to put the fiber one by one. If we use the people, we need to go a very long way. For example, we need a very long trace, very small. So we developed a bending active system use a fiber reinforced polymer using the robot arm. If people to move this system, it's cost a lot of time, but for the robot machine, it's very easy. For example, this is a very simple case. If we use a traditional method to build this arch for bridge, we just use the crane to build this arch in one time. Yeah, but we use a robot. We use a very small bar of FRP. Use a GFRP rod. Use a robot, make it one by one. So this is another case. So use this method, we can make the structures use a smaller components, use a robot, but more components for one structure. So so we build this saddle shaped curved spatial structures. We use more than 5,000 meters FRP road. So robots can very efficiently to complete this very complicated structures use this method. And another case is masonry. Actually, we know masonry. We are familiar with masonry, traditional masonry. In the first generation to the second generation, why we use a block, why we use a block, why we use a brick, because the people can lift the brick very easily by hand. But during the construction, we use the regular brick to make the structures. For the lightweight, it's very easy for the robot. It is a suitable to the robot's construction. And but now we can upgrade the masonry structure based on the robot and the 3D printing. We can use irregular blocks. For example, the this one we develop the interlocking design. That means we don't need the mortar between the concrete between the block. It use a irregular block interlock each other, and it is very complicated for the assembling by people, but it is easy for robot. So this is a basic concept. If we use a traditional method, and we have to use a regular block, but we can use a robot to assemble the irregular block, and we can use a robot to making irregular block with 3D printing method. So this is a new system and a new material for robot construction. Okay, this is the 3 cases. We just want to give a new viewpoints on the how to use a robot for construction. Actually, in future, we can consider the 5 levels for the automatic construction. Yeah. We cannot. We need to consider the construction. We need to consider the monitoring. We need to consider the troubleshooting. And now we are in the level 2, I think, maybe on to level 3, and now. But in future, we hope to realize a kind of the scenario like this. We can see a site use a laser scanning by the robot automatically get the geometric information, and use the AI automatically design the architecture, get the shape and the function, and then design by the AI divided into the irregular blocks with the interlocking, and then printed by the machine, the irregular, yeah, of course, and use the machine onset assembling, then make a structure. After it, we need the intelligent detection and evaluation. Use the robot also. Now we just need detection robot, and to AI for design, and 3D printing, and assembling robot. We need 3 kinds of the robot. It's okay. So this uses kind of the mercenary system. All of the jobs we don't need people involved in the system. Just the inspection is okay for people. And now we need to consider the brain, eyes, hands loop for the robots. In most of the cases, we just consider the robots to replace the hand. We want to consider this loop integrated, and we need to consider the automatic the robot as a hand, and the help us to censoring the structures to get the information, and we need the AI to design. So we need to combine them together with digital twins for structures. This is our in future we want to do. Finally, in one word, the robot and the AI can give them our new functions and for the construction tools. But finally, we want get new buildings and new bridges. that means we don't want the traditional, the concrete or steel in the second generation material to build the building and the bridge. Actually, because we need the new life, we need the new tools to build the new system. So that is main meaning of my presentation. Actually, I hope to collaboration with the researchers developing robots together to make the next generation with the construction and structures, buildings and bridges. That's all. Thank you. Hello.
All right, thank you very much, Dr. Feng, for the presentation. For the sake of time, I think we'll have to take a break for lunch. And if you have any questions, I think you'll feel free to talk to Dr. Zhang, who is here in the room with us today. So we'll take a break for lunch and we'll come back at 1:30 for the next item on the agenda. So thank you, everyone.
Thank you.